Okay, we have another example regarding momentum equation. This is another question of PO exams. A pressurized pipe with diameter of 153 millimeters at a 45-degree elbow. The steady state flow in the pipe is 200 liters per second and the upstream pressure is 500 kilopascal. The reaction force at the elbow are equal to Rx 6 kilonewton and Ry 2 kilonewton. One question, if we reduce the diameter of the pipe, what happens? Increasing of friction or actually increasing of head loss or decreasing of head loss? Which one?
Decrease
When
because the friction area decreases.
the velocity is higher than the previous one when we make smaller the diameter, so it should be head loss is bigger than the previous one.
Yeah. When we reduce the cross section with the same discharge, actually we are increasing velocity. And when we increase velocity, we have more friction between the flow and the pipe. So finally, head loss is more than previous.
I have a question. Can we have the Moody diagram in our exam?
Yeah, pressure energy and we have velocity energy. And always total energy at the second point is lower than the first one. The difference between these values is head loss or HL. So if we calculate the energy of the second point, point B or point 2, then amount of energy at point B always is less than amount of energy at point A, and the difference is head loss. So we can write HA is HB plus HL.
We have the same velocity in the point C as the P1 because the flow.
Sorry, I'm not talking about this case when diameter for P1 and P4 are the same. I'm talking about this case with different diameters. When we have different diameters, we have different velocities.
Yes.
And the question is, which one should be used for calculation of velocity head at C when we have different velocity?
I think it's a transitional phase, so one of the
V4.
formulas.
I think the maximum one should be chosen.
Okay, maximum is V1, right?
Yes, it's more critical.
Because when you have higher velocity, you have higher energy, right?
Yes.
In this case, we don't have this situation for this node. For other nodes, for example, you have one pipe here, another here. So
but
you have three velocities.
But Mr. It does not make a sense. I don't know why I confused, because when we have the velocity in the pipe 1 and we arrive to the point C, actually the velocity of the flow is the same as in the P1. It's regardless of the maximum or minimum of the speed. If the flow is from A to B and we have the flow in the pipe, actually we should have the same speed with the pipe 1 in the point C. It's in my mind, maybe I have a mistake. Please correct me if I can understand something.
So in this case, for this case, velocity both sides of C are the same, right?
Yes, but of course.
I'm talking about this case when we have different diameters both sides of the node.
I take totally when we have a flow from the point A to point B. When we move from the A in the pipe 1, we have the same velocity when we arrive to point C. In my mind, it's something like this, not the maximum
velocity from the beginning of point P1 to the end point of P1 is the same.
No velocity.
The
Zero.
velocity is 0 at
Zero.
point 1.
Yeah, because on the surface of a tank, we have no motion, no movement, so velocity is 0. So P1 over gamma and V1 squared over 2G are 0, and we have just H1
We have to record this
values.
amount in our mind.
Yeah.
Okay.
For this exam, you have, you allowed to have a paper to write the equations and formulas. Also, you can write these parameters.
Oh, nice. Okay.
Compute the discharge capacity of 3-meter concrete pipe carrying water at 10 degrees centigrade. It's allowed to have a head loss of 2 meters per kilometers of pipe length. So what we have, diameter is 3 meter, water temperature is 10. We have these parameters for all pipes, and in this case we use L equivalent instead of K equivalent. So first of all, for these pipes we have serial condition, so L1 and L4, and also P2 and P5 are in series. We can calculate equivalent for L1 and L4 and L2 and L5. Based on the formula I provided before, for equivalent case based on L, we have this formula in serial case. So L1L, L14 and L25 are equals, and finally we have 400 meters. Then for this part of the network, we have L14 and L25.
Dear Farzin, I got one.
So because for each pipe we have these values for K, finally head loss for each one is 1.5. Also for L2, L5, we have the same situation, and we have the same head loss for P2 and P5. Okay, then continue on this part. L3, 6, 7, 9. We calculated head loss between A and H.
Dr. Fatima, I have a question. If it's possible, instead of the L, we can use the same as last session. We can use the K equation.
Yeah, we can use K equivalent, but definitely when you use, for example, K equivalent, you need additional calculation for K, right?
Yeah, yes.
In previous example, my emphasis, as I sent in the chat, my emphasis was on calculation of K, because it's a general solution for the case we don't have similar parameters for L, D, or other parameters, C, or everything, right? But when we have similar parameters, we can calculate based on other parameters, and then you don't need to calculate F. Sorry, K.
Teacher, because I calculated and I get the same result from the L and K. Both of them is same.
You mean for this question or previous?
Yeah, for this question.
For this question.